Now let's take a look at a question that is the opposite of what you were doing in example two. So here, we are given a specific area and we're asked to then find the missing value. And the missing value here would be the height that corresponds to a specific area. So using the same distribution for women's height, where we know that women's height is normally distributed with a mean height of 64 inches. So I'll write that down. Mu is 64 and a standard deviation sigma is 3. What is the height that corresponds to P sub 25? Meaning, what is the height that is in the 25th percentile? So the height that's in the 25th percentile is going to be the height that separates the bottom 25% of all female heights from the top 75% of all female heights. And so I'll show that in the distribution below. So again, anytime that you know you have data that's normally distributed, go ahead and draw yourself that bell-shaped curve. And so now I'm going to shade in an area that is approximately 25%. So this area in red represents all female heights that are in the 25th percentile. So again, this red shaded area separates the bottom 25% of female heights from the top 75%. So I'll shade the top 75% of female heights in green. Okay. And that area is 0.75. Okay, so again, our goal is to try to figure out right here what female height, right, separates the bottom 25% of heights from the top 75% of heights. And we should be able to also calculate a z-score that corresponds to that height. So what you want to do here is you want to start with the z-score if you're using the z-table. So if you go to the negative side of the z-table, and I'm choosing the negative side here because P25 is going to be on the left tail of the normal distribution, you're going to search the body for where you find a decimal that will round to 0.25. So hopefully you can see here on the right, I'll circle in red, that an area of 0.2483 is the first decimal that rounds to 0.25, and that corresponds to a z-score of negative 0.68. So that tells me that this z-score here is negative 0.68. So once you have the z-score, we can use that formula for calculating z-scores. Z is equal to x minus mu divided by sigma, and solve this equation for x. So if I solve this equation for x, x is going to be the z-score times sigma plus mu. And so here you can see how we can use that formula to then find the height, which is x. So this x is the height that corresponds to P25. Okay, so let's do the substitution. Our z-score we know is negative 0.68. Our sigma is 3, and our population mean mu is 64. So if you put this into your calculator, it corresponds to a height of 61.98 inches. So this tells us that a height of 61.98 inches, right, is the height that separates the bottom 25% of female heights from the top 75% of female heights. So P25 here would be 61.98 inches. Okay, next I'll show you how to do this on the calculator. So on your calculator, what you're going to do is go to your distribution. So you're going to get there by pressing second bars. And this time, instead of choosing normal CDF, you're going to choose option 3, which is inverse norm. And then your calculator is going to ask you to put in the area to the left. So if you have the newer, fancier calculators, it defaults to left. But if you have like a TI-83, then it will automatically default to the area to the left. And then you're going to type in the population mean, mu, and the population standard deviation, sigma. Once you press enter, I hope you can see that the calculator gives you the same solution as what you would get if you used the z-table. So height of 61.98 inches.